Yeah, so we want to do another analysis, repeated measure analysis. So we call up the form as before, and here is the form. Then the dependent variable's name, is in this particular one is meal. Now let's be sure. Good. Meal. And then let's say that we want to see how three of these or four, how they affected the meal. Now, first of all, we look at WTR, which is the variable names that is here. We want to use just out of the 7 variables, we want to use out of the almost 9 variables, we want to use only 4 of them here. Then WTR, yes. Then the next one is SES, yes. And that one is SAL, yes. And that one is veg. SES, SAL, veg. Then and the group now is state. State is the group. Okay. And the data file name this time around is no longer RMA data, but is some tools. That is the data file name. Then we'll process it and see how this one looks different from the other one. You can see now this is it. That's processed. Yeah, this is the box plot, and you can see the number of the states that are involved in this one: Lagos, Ebonyi, Kano, FCT, Anambra, Edo, Benue, Imo, Kogi, Abia. That's it now. Yeah, so that is for that. And then still more and more. Yeah, this is it. This is still you can see this is stacked with the line graph, so you can see how it affected them. That's the colors of this determines the states. Color determines the states, and you can see the predictors. The predictors here. The first one is WTR, of course. Then SES, SAL, and then veg. So these are the effect of each of the predictors on the meal, and according to the states. And of course, this is another box plot showing the states. Yeah, this is a beautiful histogram stacked bar charts for days. You can see the states as colored, and then with the different types of this thing there. That is the different types of the predictors that they use. Now let us look at this is the predictor. This is the predictor for that. You can see. This is as usual the data set used, and this one, the ANOVA. The ANOVA the data set used, the ANOVA is 3. The ANOVA here is showing the results. That's the F value is 163.1704. The degree of freedom is 3 stroke 27, and then the probability is 0.00, which means this is a very, very fit, model. And then of course you have the monthly sphericity test. The sphericity result is true with these values. It's true with these values. So you can see that here. And then you have the Shapiro Wilks test for normality. Look at the statistics here, and then the p-value is here. And then you have the Levin test for homogeneity of variances. You have Levin 1.0, 0.4 through, and so on and so forth. And then you have Tukey's pairwise HSD post hoc test, which is this, all saying that we should accept. We should not, all saying that we should not reject the null hypothesis. We should accept the null hypothesis. You can see everything is you can see how it is comparing group to group, comparing state to state. In this case, you have Abia and Anambra. First of all, you have to compare all Abia with all the other one. Abia Anambra, Abia Benue, Abia Ebonyi, Abia Edo, Abia FCT, Abia Enugu, Abia Imo, Abia Kano, Abia Kogi, Abia Lagos, and then it now starts with Anambra, Benue, Anambra Ebonyi, Anambra Edo, Anambra Edo, Anambra FCT, Anambra Ibo, Anambra Kano. Then it also goes to Benue to start comparing Benue with all others, just like that. And then it goes to Ebonyi to start comparing Ebonyi with others, and go to Edo to start comparing Edo with others. But one thing is very visible. Now, as it's going down, it's reducing the number of comparisons, because comparison has already been done earlier. For instance, the first one compared, that's the Abia compared all. But then, when you now come to Anambra did not compare Abia, because Abia has already compared Anambra. And when you come to Benue did not compare Abia and Anambra, because they have been compared. Then when it comes to Ebonyi did not compare Abia, Anambra, and Benue because they have been compared. And when it comes to Edo did not compare Abia, Anambra, Benue, and Ebonyi because they have been compared. And when it comes to FCT did not compare Abia, Anambra, Benue, Ebonyi, and Edo because they have already been compared. That is how it is, and it continues to whittle down until Kanu, Imo compared 3 because the others has already been compared. Then Kanu compared 2, and Kogi, which is the last one, compared only 1, and that is Lagos. So that is how the whole thing is. And Lagos does not need to compare anyone because everything has already been, every state has already compared against Lagos. So which means that you can always read it from the states just like that. And then the Profreni post hoc is also showing false. That is that we should not reject the null hypothesis. And then the Profreni p-value is 1.000, which is very, very insignificant at all. Then Bonfreni t-test is 0.001, which is that. And then here is showing us that we can still get the result of this analysis in the value stats RMA results .txt, and the plots also where this is. So now let us go to the let's see if we can see what this is talking about. Okay, look at it now. Yeah, let's see. The RMA results. Yeah, the RMA results, exactly the one that we just finished. Yeah, good. You can see the same thing that was there is what is also here. So this is the one that enable you to print. Now, the line graph for the same, you can always record them. You can see it. That's the line graph according to state by state. Look at Lagos. Look at Ebonyi. Look at the line graph is comparing, the dependent variable, that is each of the participants with the dependent variable, how they fared according to the dependent variable. That's that. And then you also have the box plot showing you the same thing. And then you have the stack line graph. Yeah, this one is showing, this time around, it's showing the effect of the predictor variables, on the states. But this time around, it is stacked line graph. That's the states giving different colors. But then you can see where it's a very beautiful graph anyway, and it tells a lot of stories on that. So, and then the histogram. Yeah, this histogram is also like the stack line graph. So each of the states have their own value and so on and so forth, and then they are compared. So that's about that. So now Yeah, so having finished that, now let's look at another one we want to do here. Now we still go to the analysis of variances. We are finished with repeated measure. Now let us look at the multivariate ANOVA. Yeah, the multivariate ANOVA is the one that compares a lot of things, a lot of values together, and then see how they relate with themselves. That is how they vary, that the means of those things vary. And here, a dependent variable, wow. Let me see if I actually have